We want to determine whether the series is absolutely convergent or conditionally convergent or divergent. So with this one, I would do the ratio test. With the ratio test, we take a sub n plus 1 and have that over a sub n in our absolute value. And we take the limit as n approaches infinity. So what is our a sub n plus 1? A sub n plus 1 is going to be negative 9 to the n plus 1 times n plus 1 times 10 to the n plus 2. Our a sub n is going to be our original. So I'm not going to write that. Now we can multiply by the reciprocal. We can multiply by the reciprocal of the original because that's the same thing as having divided by it. So we multiply by the reciprocal of it, and we take the absolute value. So this would be n times 10 to the n plus 1 over negative 9 to the n. And now we can cancel stuff out. So what do you see that cancels out? Well, we have negative 9 to the n times negative 9 in here. So that gives me something to cancel out. I can cancel out this with this. What else? We do have 10 to the n plus 1 times 10. 10 to the n plus 1 times 10 would be the same thing as 10 to the n plus 2. So this cancels out. And that seems like that's it. That's everything that cancels out. You certainly can't cancel that n with that because that's being added there. It's its own term. And so we're left with negative 9 tenths times n over n plus 1. This becomes positive, obviously. We apply this absolute value, and this is just 9 tenths. Now we can divide everything in there by n. So this is 9 tenths times n over n over n plus 1 over n. This is 1, and we're going to plug infinity into here, which will give us this going to 0. If this goes to 0, then we're left with 1 over 1, which is just 1. Multiply this by 1, that's what you get, 9 tenths. So with 9 tenths is less than 1. So that means that this absolutely converges by the ratio test. It absolutely converges because we had a term that was less than 1.